Hello friends, welcome to C# Intermediate to Advanced tutorial. In this video, we are going to see how to avoid the long-running task issues which we saw in the previous part 4. So in this part, we are going to see the DoEvents method and how it will avoid some of the issues. These are all the slides from previous parts. Alright, now we will see how to use the DoEvents. We know about this code. In the previous video we saw it when both the options are in a unchecked state. Let's forget about this one. When use background worker checkbox is in unchecked state, the time we will land up here. After calculating the progress update, okay, here we are calculating the progress value, then we are updating the progress bar. After this, we can ask the application to do the other events. So this is how we call the DoEvents. And if you see chk use DoEvents, so this is the checkbox, chk use DoEvents check state. When it is in checked state, we call this function application.DoEvents. We will see more about this, and before that, here what we are checking, chk use background. So here also the event is chk use background checked changed. So not this one. First here we are checking this one. So the event is handled for this checkbox because the name for this checkbox is chk use background. So when user places a check mark or removes it, so that's what called checked changed, and it will call this event routine. Inside we check the background chk use background, the same checkbox, and when it is in checked state, if you see the DoEvents, so this is the DoEvents, right? DoEvents enabled equal to false. That means we are disabling it, and at the same time we are, if there is any check mark previously placed, we are removing that. Check state equal to unchecked. So when you place a check mark here, we are disabling it, and at the same time we are removing the check mark if anything is already placed there. Otherwise in the sense, if we remove the check mark, we will enable the DoEvents. So this kind of validation we can easily avoid it using the radio button. Since the initial design we used a checkbox, so we have written it like this. Now we will come back to this DoEvents. In the previous video we saw that application was hanging and we are not able to proceed with the cancel button click also. Now let's say this is the main UI thread. So this will be the application, and it will have a event dispatching mechanism, and it dispatches the event, and those events run in the main thread. And let's say this is the a long running, or this last one is the long running task. So if you see here, this is the main UI thread, and this one is the long running task. And Let's say there are other events also, those will be here. So likewise, the UI interaction will be processed by the single thread. So let's say this is placing a check mark here or removing a check mark. Let's say user placed a check mark here in use background worker component. This is one UI action, and there will be a event routine for it. And let's say user moved this window from one location to other location. So there will be multiple such events. Why? Because mouse move will fire many events, right? So if it is moving from here to here, before moving there, the event will be continuously produced. And let's say these are all the events too. And this one will be the long running task 3. And once again, this is a mouse move. Let's consider like that. So these are all the sequence. So what happens when you place a check mark here, the execution time for this will be definitely very less. Why? Because it's not a long running task. It will be done in a fraction of second. Let's say FS. In fraction of second, this one will get finished. This one in the sense placing a check mark or removing a check mark from here. The event will get handled and it will get finished in a fraction of second. Second, moving the mouse, moving the window using the mouse move from one location to another location. Just for example, we took the move produced just 3 events, a small move. And if you see, even though it fired 3 events, all will get handled in a fraction of second. So maybe let's assume this took just a half second, 0.5 second. So you won't see any hang here. Now on the main UI itself, we are doing this long running task, right? This takes 10 seconds. Let's assume like that. This takes 10 seconds. And when this is in progress, if a user wants to move the mouse, if they tried to move the mouse, nothing happens. Why? Because the main thread is already busy here, and these events won't run until this 10 seconds elapses or until the long running task finishes. So that's why you will see a hang. If you keep on producing the event, Windows will show a gray window. Gray in the sense a transparent or whitening window. All right, now let us come back here. Application.DoEvents. So now we know that this will be the long running task. Now let's project this here. All right, we know that this code runs in a for loop. For each character, we will do this processing. Here we placed a code for application.DoEvents. So we are calling application.DoEvents on a conditional based. That means once user placed a check mark here, we are checking that, then we are calling the DoEvents. Let's state this is the call A, and let's assume that here we are calling A. So what happens after processing one character, it will ask the application to do the events. So in that case, what happens? Now consider this picture. Application is running here, and at this stage we are deliberately asking the application to do the event. So this is the application, right, which is dispatching the event, and the event handler runs in the main UI thread. So we are asking the application to do the DoEvents. So this means application will halt this for a moment and it will check back the event queue. So let's state this is the event queue. As already told, 1, 2, 3, 1, 2, no issues. Those are all already processed. So when this long running task is happening, let's say user moved or user clicked some of these checkboxes, or let's say user is moving the window. So in that case it will be queued, right? And what happens when we ask for the DoEvents, this code will hang. This code in the sense the long running task. So the long running task at this stage will gone into the sleep mode, and application will check for is there any event user produced during this long running. Application will perform or call the handler for this task. That means even though mouse move we doesn't handle it or we doesn't provide any handler code, the handler will be available in the C# framework itself. So what happens, the window will actually move from one location to other location. All right, then all events are cleared, right? Once all events are cleared and there is no more event, then application will take back this long running task. So this is sleeping here, right? This will wake up and runs the next loop, and when next loop runs, once again we will call this DoEvents, and application will check is there any event queue here. If there is no event queue, it will proceed next. Likewise, it will keep on going. So on each iteration, it will check for the DoEvents, and if there is any queue, it will clear those queue by handling it. So when we go to our demo, what we can see is we can turn on this DoEvent, then we will try moving this window. So when you try to move this window, you can see that the main thread will hang. I mean, we will move it continuously for a long time, slowly and continuously. For 4 or 5 seconds we will move, and you will see that this long running task will hang. Since long running task will hang, you won't see the progress update, you won't see the count meter update. And once you stop your mouse move, that means all event will get processed, then it will resume back and you will see the count meter is going on. All right, that's all here with the DoEvents. And if you see, we solved the problem of updating the UI, but at the same time, when user is doing some action here with the window, it disturbs the long running task. So that's what we are going to avoid in the next video by using the BackGroundWorker component. All right, now we will go to the demo. So this is our code, and you can see this function do without background will get called when user clicks the start count button and when there is no check mark in the use background. All right, now we will go ahead with our new code. Here we are calling the DoEvents. So now we will handle the use BackGroundWorker check changed event. Checked changed. So that's all the code change. So these snippets were added as part of the previous video. In this video, we added code snippet 7, which is inside the do without bkgrd function, and then we handled the event. Now we will check this. First, if you see, I'm starting the count without this DoEvents. You can see progress bar is updating, but once I started moving the mouse, it's gone into not responding state. You can simply see that I am not able to move the window. So once it is completed, the move happened. I will do this once again. So this is the place I want to move. Released my mouse cursor and it is not responding. Waiting for the long running task to finish. Once it finished, you can see the window moved to the cursor location. Alright, now we will use the DoEvents. So now I'm clicking on the start count. You can see the progress bar is moving on, and at the same time the count meter also updating in real time. But the moment I move my window, I have to click once again and move. And if you see, the long running task is not proceeding. Also you see in the top before the multi-line text, count in progress. So what happens here, I'm moving the window continuously. So the DoEvents get called and window is processing that DoEvent, and application queue is continuously getting this mouse move events. Mouse move events are continuous, right? If I am moving from here to here, there may be 1000 or it depends. There will be multiple number of events that get produced. Since it is busy, it is not updating the count meter. Now I am going to stop moving it and you can see it is resuming. Right? Let me try this once again. Here if you see, I'm trying to move this window. Here also, this is also a costly event, right? So the moment long running task called the DoEvents, application is busy in clearing these events, this move. So since it is clearing these events tied to a single thread, the long running task, which is also running in the same main UI thread, is waiting for its turn. Alright, now I will stop scrolling. So application queue get cleared and now we are back to our long running task. So this is the disadvantage here. Even mouse move, here I am resizing, this is also costly event. Typing won't do anything, it's not that much costly. Alright, and that's all here. Now you know what is the use of DoEvents and how it cleared some of the counting operation. Now I'm clicking the cancel here. You can see the cancel also I can able to proceed. Previously I am not able to do cancel. Actually we can able to do the cancel. The cancel is tied to a event routine that goes to application message queue and it stays in the bottom. Once long running task finished, then it picks up the cancel. But what is the use? Because long running task finished and the cancel is meant to stop this long running task in between. So that's how it doesn't work in our previous video. Now we used DoEvents and now cancel get called and it ran, and next time when we come here, if you see here, this is the long running task. Somewhere we check this cancel operation. Who is calling this? Here we are calling it. Alright, do without background. Here we are cancel work false. Okay, here we are checking it, right? So that's how the application gets stopped in between, and the event routine for cancel is here and we are checking the cancel work to true. So this event routine is called in between. So that's the usage of DoEvents. because of do events here we are clearing the pending UI event. That's all here in this video. Thank you for watching. Bye.